Another advanced design technique is the use of many-to-many relationships. There are many reasons we might want to create this type of data model for our cube. I've included a resource at the end of this presentation for a more in-depth look at the possibilities. For this presentation, we'll focus on a concept called a multi-valued dimension. Most of the time, a fact table has a many-to-one relationship with each dimension. For example, it's possible for many fact records to relate to a single customer. Now let's look at an example of what a many-to-many relationship looks like. First, consider a multiple choice question like, why did you buy this product? Choose all that apply. From an analysis perspective, we might want to know how many sales were because of price or because it was on promotion. So we set this up as a many-to-many relationship. We set up a separate fact table to show the breakdown of sales facts by sales reasons. A single product sale, corresponding to a sales order number and a sales order line number, can have 0, 1, or many sales reasons. Notice that this table does not have any numeric values, known as measures or facts. We call this a factless fact table. It might also be known as a bridge table. To help us perform analysis of sales by sales reason, we need to factor in relationships with the Fact Internet Sales table where each product sale has its own row. Technically speaking, a bridge table usually sits between two dimensions, and it does here too because we consider sales order number and sales order line number to be a degenerate dimension. It's a dimension that we've modeled as part of the fact table so that we don't have to join two very large tables together in a relational query for sales order number information. As we'll see in the demonstration, we go ahead and build a standard dimension into analysis services for the degenerate dimension that we find in the fact table. Because we can now relate a single fact row in Internet sales to multiple sales reasons by having the degenerate dimension and the bridge table in place, we call this entire structure a many-to-many relationship. That is, many fact rows can relate to many dimension rows for sales reasons. When we look at this structure as we browse a cube, we'll see that the same sale shows up in multiple sales reasons. But that doesn't mean that we increase the total sales. With a many-to-many relationship, the grand total always reflects the true grand total. Now that we see how the relational data is modeled, let's see how we tie the pieces together in analysis services by configuring dimension usage. Before we can do this, though, we need to add the degenerate dimension and the many-to-many dimension to the cube, and add the bridge table to the cube as a measure group with a hidden count measure. When we add these items to the cube, analysis services should automatically detect and add regular relationships for the degenerate dimension and the many-to-many dimension, which is sales reason in this case, and these regular relationships exist between the dimensions and the bridge table. In addition, analysis services should see a fact relationship between the original fact table and the degenerate dimension. The step we'll need to perform manually is to set up the many-to-many relationship between the fact table and the dimension, and all that involves is selecting the bridge table in the intermediate measure group drop-down list.